Hello and welcome back to another episode of PEEPanEIP, an educational video series where we discuss an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to discuss EIP-3860 limit and meter Initcode with the co-authors of the proposal, Alex and Paweł. EIP-3860 is a standard track code proposal initially proposed in July 2021 and is approved as a consider for inclusion for the Shanghai upgrade, which is the next planned upgrade and expected after the merge. So I welcome the guests for today, Alex and Paweł. Maybe we can start with a very small introduction and then we can jump directly onto the presentation that we have for today.
Yeah, thank you, Pooja. I think I'm just going to start quickly. Yeah, my name is Alex and I've been working on Ethereum for several years now, both on the Solidity language as well as with this team on various improvements to the protocol itself. Initially, the team has been called EWASM, but last year we have rebranded to Epsilon because the work we have been doing has been way beyond what EWASM was about. And for the past 2 years, we have done, actually not two, at this point it's like 2.5. We have done a lot of research on the execution layer, and more specifically on EVM improvements. But we not only create proposals on from our end, but we also do review other proposals made for the EVM.
Hi, my name is Paweł. I started working on EVM very early back in 2014, and since then the journey mostly follows what Alex explained. So I was working on EVM in early days. Then we had a period of WebAssembly excitement, and we are back to EVM right now. So yeah, my work is mostly maintaining C++ implementation of EVM and proposing and reviewing other proposals for improvements.
Well, thank you so much for introduction. I know people are looking forward to learning this proposal, so let's just peep in.
Okay, nice. So yeah, my name is Paweł, and I will try to go through the proposal, which is EIP-3860 limit and meter Initcode. This is currently under review status, and it's considered for inclusion in Shanghai network upgrade, which is the one that will happen probably after the merge. So the proposal, like if we start with the describing the specification, it adds two features to Initcode. One is that it cannot exceed some specific limit in length. So we don't want to the Initcode to be unbounded, and we put some specific limit on the size of it, and I will try to explain why exactly this number is shown. So this is around like almost 50 kilobytes. And secondly, we also want to charge some additional gas cost for the preparation of the Initcode before execution, and that's the cost of it should be 2 gas per 32-byte chunk of the code. So maybe like quick technical explainer, what is the code and what is the Initcode in this context. So when usually people refer to code in Ethereum context, they rather mean the contract code, and this is also how it's as it's mostly named in technical documents about Ethereum. so this is the code that it's actually stored in the Ethereum state, and this is the contracts code that is being executed by transactions. But there's some kind of a different kind of code which we called Initcode, which works as a constructor to contract creation. So like Solidity refers that to the constructor. I think the constructor is not like technically very much used in the Ethereum technical documents, but anyway, this is kind of ephemeral bytecode, which works pretty much the same as other bytecode if executed in EVM, but it's not stored anywhere, and its job is to actually produce the code that will be deployed to the state. And like as I mentioned, we want to actually limit the maximum size of the init code, the maximum length of it. So the contract code, what I mentioned is it's already bounded to some number, and that was introduced very early in the history of EIPs. You can guess by the number of the EIP 170, and this limit is around 24 kilobytes, and you cannot store bigger code, contract code to the Ethereum state than this one. But in case of init code, that can be of any length. It's not really like it might be difficult to create a transaction that has a lot of init code because some of them are pricey, because they might be either be in memory or in the transaction data, but there's a way to kind of amplify this effect, and you can have multiple init codes in a transaction for different creations that adds up to the total length. So we want to limit this particular single one of it. And the constant we aim for is double the code size limit. So this is where the number comes from. And secondly, we added this additional cost related to the number of bytes in init code. And this comes from the fact that you actually need to, for every execution, for every bytecode you want to execute, you need to perform the thing called JUMPDEST analysis, which tries to find the valid targets for jumps in the code. And because the init code is ephemeral, and so the cost of analysis is proportional to the length, but there's nowhere directly expressed in this way. So there's no cost currently for the length of it, and that creates some technical challenges for the implementation, at least. So why do we apply this cost only to the init code, not for the code? The code, when you deploy a contract code, you already pay 200 gas per byte. So this is like way bigger than the cost we are talking about in case of init code. And secondly, even if the contract code can be executed multiple times and deployed only once, there is not so difficult, if that would be a problem, to actually do also the JUMPDEST analysis once and keep it somewhere around the code. there are multiple approaches to how to exactly cache it alongside the code. I will not go into detail. I'm not sure like many implementations actually do that, but we think it's like technically there is not so big risk in this aspect here. And where the number of 2 gas per 24 byte chunk come from. Maybe starting from the bottom of this slide. So we compared Keccak 256 instruction performance, which also like mostly goes and process some number of bytes and can be on of arbitrary length byte array. So this is like similar complexity. And we kind of performed the performance of that in one of the implementations with the performance of the actual JUMPDEST analysis of a byte code. And we also wanted to be like, we kind of aimed for like, for the value that is pretty low, in our opinion, to actually limit the impact of that to existing contracts and to newly deployed contracts as well. So we actually compared the performance of different JUMPDEST analysis implementations, and GEF actually has one of the best ones. I mean, it's actually the best one from the ones we tried, because they really put a lot of effort to optimizing it. So that's kind of the baseline, and we think that's not so technically impossible to implement it the same way in other implementation, if that's a trouble. And so like combining all of this together, we pick the lowest value we think are reasonable. And yeah, so I wanted to like quickly maybe explain what is this JUMPDEST analysis about. So what I want to like unfold here is like, what is it and what it like, why it's needed, and if you can visualize the bytecode with the opcodes in it. So when we consider jumps, the validity of a jump target is prescribed that the jump, like the target of the jump, must be a special opcode called JUMPDEST. So whenever you actually have some control flow in your code in EVM, you cannot like jump to any instruction. It must be precisely the JUMPDEST one, which is encoded as 5B in hex. So that's kind of easy to check if the byte you're jumping to is actually this one. But there's like complication to it, and is the fact that some of the instructions, and currently all the push instructions actually, have these immediate bytes following the opcode. In these examples, I put like push 5 instruction, and it has like 5 bytes of data, how we call it. And we don't want to consider these bytes as a valid JUMPDEST. So in this example, if the 5B byte is in the data, let's say, section, we don't want to consider that. So mostly the JUMPDEST analysis need to scan the code and to collect all possible JUMPDEST positions. And to do that, you also have to inspect the push instructions in the code. There is no easy way to like not doing it from the beginning to the end. When you would be like on any position, you can't figure out what's going on around you unless you start from the beginning. So that's some kind of challenges. And so this like cost of doing that, it's proportional to the size of the code. That's why we want to kind of express that in the gas cost model. And we want to also charge proportional cost of Initcode analysis. So this is like the second level of questions that can come up with from that, like why this JUMPDEST is actually needed, and yeah, and why we don't want to execute the data bytes around the push, but I think it's a bit out of scope for now. But if someone is curious, I will try to explain that at the very end if if we have time for it. Okay, and yeah, so that's mostly was the description of the EIP and a bit about JUMPDEST analysis, and finally that's what we discuss internally and try to actually collect some information from the outside, is about the Initcode length limit. So we put two times the code length limit. So the reasoning for that is that the Initcode works as a constructor in, for example, in Solidity and like most of the cases. And how it works is actually has how the constructor code is structured, is that it has some code at the beginning, and in the end, after it does some fancy logics encoded by the contract developer, it actually copies bytes from the rest of the Initcode and to produce the code to be deployed. So so I think one of the property we have to include is that the Initcode limit must be bigger than by the code limit. And they are kind of tangled, and probably if we want to go to increase the code limit, we also need to increase the Initcode limit. And in the specification, we actually use the constant together, so it's expressed as a 2 times the other constant for whatever it matters. Yeah, so for us, I think it's reasonable value, and it has some nice properties that, for example, the offset in the code will never exceed 16 bits values, which can be exploited in some implementations. However, we did some analysis of the usage. What happened on mainnet so far, and along lots of spammy transactions and spammy calls that were really exceeding the limit by a lot, which we can ignore, I guess. We found some use cases that actually exceeded already. And this is example that's I don't think you can actually see the whole hash of the transactions, but we found one transaction that actually deploys 11 contracts in one transaction, and they used over 25 million gas to do that. And the total Initcode transaction is actually two times bigger than the limit we put in. So that's kind of tiny question we have, maybe we should reconsider. However, we didn't receive any feedback that would suggest that it's really necessary. And so far we kind of on the position to keep it as was specified. yeah, so I think that's all I have to say about it. At least, yeah, what I can see from the sides. So I might want to go to like give a voice to my colleagues for now, and yeah, we're also open for questions.
Well, thank you. Thanks for the presentation and congratulations for this proposal to be in CFI. I know that there are a handful of proposals which are up for Shanghai. Well, I have a few questions related to this proposal. The first one is about the security consideration. Out of those 3 points which I can follow, one of those are this proposal talk about introducing a failure mode for layer 2 projects. And it further states that the authors of this proposal are not aware of any such contract. So I'm curious, as a developer, could you think of any such use cases where such an L2 project may be designed?
So I don't think that's really affects L2, although my knowledge about L2 requirements are not like probably fully. So what L2 are currently like kind of struggling with is the transaction data. I mean, they use transaction data to actually store L2 data on L1. And this data is not supposed to be executed, to my understanding. So I think the difference here is that this limit doesn't apply to this use case. So we can still have transaction data that is long as you want to pay for, and this is fine. So what this limit affects is the transactions that are explicitly created contracts on L1, which I don't think is the case for L2 anyway. So mostly the affected use case is when you want to deploy a really big contract system that you have multiple contracts and you want to do it with single transaction so that it will create. So we need to actually inject a lot of init code, which has included the code of individual contracts to be deployed in this one atomic operation. And so that's more or less the example we gave in the end. But yeah, maybe I'm not understanding some aspects, but I don't think that's actually the use case L2 cares about.
That's right.
Maybe,
yeah, please go ahead.
Maybe I would just add that, at least per my understanding, the checkpointing or even any kind of like fraud proofs from L2s on mainnet would not be done through contract creation. Rather, they would be just sent as call data to an existing contract. So there's a distinction between call data versus just generally call data versus the specific contract creation transaction, which is a very specific kind of transaction. And we only introduced this charge to the contract creation transactions and not generally to call data. But call data itself already has a gas cost.
Right. I was generally wondering, like, any kind of survey by the protocol support team may be helpful to decide on this part, if at all you guys think that it can be of worry or people might want to consider this.
Well, I mean, it's definitely a good point.
Right, because I was wondering, like, when we were deploying 1559, there were a lot of surveys, and even for 4399, when it was brought up, like there may be some project their contract may break because of that. So generally this kind of survey helps, and Shanghai is a little far from now, but given the time we have, I was wondering like this might be useful. All right, my next question related to security consideration is about the gas limit and the increased attack cost. So it's mentioned in the proposal, like currently on London with 30 million gas limit, it would be possible to trigger JUMPDEST analysis of a total of 1.3 GB of init. With this proposal, the cost for such an attack would increase by roughly 80 million gas. Can you please elaborate how this is good or bad thing for the Ethereum mainnet?
Yeah, so going a bit back to like the one question before, so we actually, like from the like client implementer's point of view, we actually received like I think a lot of support for this change, mostly because of the security risk. And the proposal mentions this kind of attack when you can like construct a transaction that mostly tries to produce as much init code as possible. And yeah, that's like serious concern currently. So the way to kind of mitigate it at the existing mainnet is to like really carefully optimize the JUMPDEST analysis. So make sure like it's as fast as possible. And there are even some trade-offs you have to make, for example, to what makes the jump instructions slightly slower because of that. Yeah, so this proposal mostly mitigates this security risk, in my opinion. So the cost of it is, as explained, we kind of pick quite low one. But in our opinion, if the JUMPDEST analysis implementation are not done wrongly, I think it's enough to protect the network.
That's a good thing to know. Thank you.
So one more thing, we even considered to deploying the EIP earlier with the previous hard fork, but in the end it was decided that because the previous one was only moving the difficulty bump, right. And I think the clients decided to just keep away the features changes. So that's why it's scheduled for the next one.
Right. The last one that occurred in November 2021. December 2021. It was only for pushing the difficulty bomb, and most of the feature proposals are for this upgrade, the Shanghai upgrade. Yes. Well, that's a good thing that this is finally in the CFI. So we are hoping to see this proposal down soon, and will be helpful for the network. My next question is related to motivation. So I agree that providing context is good, but in my mind, when I was reading the document, it seemed to me like the 3 reasons for motivations were good enough to move the proposal and definitely motivate clients to implement that. I was wondering, how helpful do you think the mention of the vulnerability situation before get 1.6.5 can be for the future client implementers making a decision whether to accept or not to accept a proposal 3860? And maybe in simple words, I'm trying to get some information about the reason behind adding history in the motivation, whether it is directly related to solving a problem or not.
How to explain that? To my understanding, so this is kind of like in the same time like known issue of EVM, but in the same time not everyone were like fully aware of the situation. So kind of in the same time when the proposal was being drafted, there was the benchmark of this JUMPDEST analysis done by other team that showed like some implementations actually need to improve right now. But that was like partly mitigated, but still that was kind of the indication that we actually need that. And that's also like, I think puts the gas cost model into more practical state, that like it actually more precisely describes what EVM has to do to do some things.
Right. Having information is good, but I was wondering, especially because this seemed like too much information, and I was just wondering, like, what could be the thoughts behind considering this, and maybe possibly updating the motivation section to the just 3 reasons that has been clearly defined in the proposal, and that can be the main reason for motivation here. All right, there is one final question, and it is related to the discussion tool link. The proposal suggests applying an extra gas cost of 2 for every 32 byte chunk of Initcode. There is this question by a user at discussion tool link, and it suggests that, what do you think about non-charging 32K or gas when the returned deployment code is empty? Can you share your thoughts on that?
Yes, so it seems to be some confusion where exactly the cost is applied. So we don't. Yeah, so I think the question is, in case of like failing create transaction or returning like empty contract, that's my understanding of the question. Can we avoid charging charging for the init code length? So I think no, because
no, I actually think the question is different.
Okay.
So there's a 32K gas cost for contract creation, and I think what the person is asking, if the contract, if the init code returns empty code, then this 32K cost should not be charged. And I believe this is motivated by them trying to use init code as just a way to execute code without creating anything and making it cheaper. This is a valid discussion to be had, but I don't think this is related to the EIP at all. Because this is a different cost which we are not introducing and we are not changing. And what, and sorry for interrupting, Paweł, I guess what you wanted to say is, even if the deployed code is non-existent or existent, the charges we are introducing are for the init code, which has to be analyzed, even if you return empty code in the end.
Yeah, so like in other words, to allow any code to be executed, you need to kind of charge this JUMPDEST analysis cost, and unfortunately Initcode is like very sensitive to that. The other code is kind of less because there's a way to implement it in a proper way that it doesn't really matter, but in here, yeah, that's a problem we actually want to solve with this one. And yeah, I understand now, like, I think this like valid use case, and that was discussed some time ago in some other places, that to have some kind of mechanism in EVM in general that would allow you to de-execute ephemeral EVM code to do some things, let's say in an atomic way, but yeah, either it's constructed somewhere else and doesn't have to be related to the contract creation. So I don't think we have such a thing directly right now. Yeah, and what I can say, there are probably a lot of ideas how to extend EVM usability. That what might be one of these.
Well, that's a good thing. Like the proposal is in review status, and if there is any kind of discussion needed, people are free to share their thoughts. But it seems like this particular question is not directly related to the proposal. So as Exec was saying, maybe this is a discussion, but for a different place, maybe. Thank you so much for your answer. That's all we have got on question list for today for EIP-3860. Any final thing that you would like to add for this proposal or share with our viewers?
I actually do. I wanted to expand a tiny bit on the actual length, which is now proposed as being a 2x of the code size. And as Paweł explained, the reason behind it is if you're deploying code, you inherently need more bytes in the init code than what the maximum code limit is. However, this code limit number seems to be a tiny bit arbitrary. It's not like a power of 2, and many people do experience the limit to be too low. And I think we are kind of open to like having a different init code size limit. But I would say that this other point, which was mentioned, that if we stay within 16 bits, which means that the init code upper bound could be 64K. If we stay within these 16-bit size, that gives us a bunch of different benefits. One benefit it gives, it can simplify some of the EVM implementations to only deal with like a 16-bit offsets. And another benefit is that a proposal like the EVM object format can also be clearly articulated with 16-bit offsets. And I think that's, and that proposal is also in CFI. So I think we would be, rather interested to keep the limit within 16 bits, but it doesn't have to be this 49K. It could be something like 65K, but it has to be bigger than the init code limit. And the main benefit, if we specify it as 2x, is that if in the future the code size limit would be increased, then this limit would, the init code size limit would follow it. If we specify it independently of it, then there's a risk that maybe in the future the code size limit is increased, but the init code size limit is missed. And then you don't really get the benefit of the code size limit increase. And another point I wanted to just briefly mention is, which is in the motivation, that if we introduce this charging per init code chunks, then this cost system is useful for other EIPs as well. So proposals which do some kind of analysis at deploy time would need to have some kind of a gas system in place for those for that analysis. And again, a good example is the EVM object format, which does a tiny bit of analysis at deploy time, and this cost would be likely covering that as well. But there are other proposals like EIP-3779, which tries to analyze the control flow of the code. And should something like that be implemented, you would also want to charge for the analysis cost of it. So once we have this init code size metering proposal in place, it is an extendable proposal. You can increase the per chunk gas cost with a single change of a constant. You don't need to change all the clients at all. So it is a future-proofing proposal as well.
That's nice. I think the EIP proposal that is 3540 and a version of it 3541 is already deployed with the London upgrades. So we hope to see this proposal being discussed in this show sometimes in near future. And yeah, thank you so much for sharing all this information. To be honest, while going through the motivation section, it felt to me like the motivation is added for client teams to consider this proposal. And somewhere I found it like, if you are convinced, it's fine. If you are not convinced, we are going to change and update the motivation to convince you more. So it looks like this proposal is one of the most convincing proposal up for Shanghai. So hope to see this moving fast. I know it cannot be moved to the last call unless it is being tested and everything else. But this is currently in the review status. So I hope information shared today will help the community and provide them some background. So if they have any thoughts, they can share it. They can share their concerns in the discussion tool link. And when we are ready with the proposal can be moved to the last call. It's time to wrap up. So on behalf of the Ethereum cat herders, I thank all of you, the guests and the participants for joining this call and discuss EIP-3860. Should you have any question on this or any other talk, let us know in the comments section and share it with us on the Ethereum cat herders Discord channel. Thank you everyone for joining us today. See you next week with another interesting proposal and another guest to talk about something that is coming up with Ethereum blockchain. Have a good one, everyone. Thank you.
Yeah, thank you. Thank you, Pooja, for organizing it.